Hey there! The purpose of this video is just to go over the notes from yesterday on linear piecewise functions. So let's take a quick look at what we did and accomplished. We had an example with 4 phases, and we graphed each phase and then came up with the equation for each one with the restrictions of the time elements. So I'm going to go through that real quick with you. JJ started at home and ran due north 8 miles per hour for 12 minutes. So right away we noticed that there is a discrepancy between the units. This is miles per hour, and that's in minutes. We had to do some conversions, okay? And it's a pretty simple conversion. If you have 8 miles, you're running 8 miles in 1 hour, you wanted to figure out how many miles will that be in 60 minutes. So by simply just dividing by 60, that cancels the hours on the units, and you're left with miles per minute. So 8 over 60 reduces to 2 over 15. So basically, he's running in the first phase 2 miles every 15 minutes. But then the time element, or how long that phase lasts, that's just his rate, okay? He runs that for 12 minutes. So if you want to figure out the actual distance, he doesn't make it 2 full miles because he's only running for 12 minutes, not 15. So we set up a proportion where we did 2 is to 15 as x is to 12 in order to figure out the total distance traveled in phase 1. Cross multiply, get your cross products, divide, and he ran 1.6 miles. So what we did on the graph is we went up 1.6 and over 12, and that's our first point, and we drew a line starting from 0. In terms of the equation, the rate is 2 over 15. He's running at a rate of 2 miles every 15 minutes, plus 0 because the y-intercept starts at 0. And then for the time restriction, it's from time 0 or minute 0 to minute 12. Okay, so that's the end of phase 1. Phase 2, he stopped to tie his shoe for 2 minutes. So this is a pretty easy phase. You're just going to horizontally go over 2 minutes and put a dot or put a point. And you are stuck at a distance of 1.6. So y equals 1.6 for that time from minute 12 to minute 14 because it's a 2-minute interval of time. Okay. Now in phase 3, when we pick it back up here, this is where a little bit of the work comes in. He continued north 4 miles per hour for 6 minutes. So if you just stop right there and consider that, again, there's a unit discrepancy between hours and minutes, you have to fix that first before you do anything. Oh, by the way, we chose minutes because the graph was labeled minutes. So we thought that would be the better way to go than changing minutes into hours. Okay. So 4 miles per hour in minutes, if you divide by 60, is 4 over 60 or 1 over 15. So 1 mile every 15 minutes. And if you look back at the phase 3, it lasts for 6 minutes. Okay. So if he's doing 1 every 15, how many is he doing in 6? So we set up a proportion again. That goes right there. Cross multiply and divide, and he went 0.4 miles, 0.4. So on the grid, starting where we left off after he's tied his shoe, we went up 0.4 over 6 minutes, and we put a point. Okay, so we are now at 20 minutes of time, and he's gone a total distance of 2 miles. But notice over here that this says miles from home. So it's relative to your location. So he's actually going to start trending or moving back home because a dog started chasing him, which he ran the entire way home at a rate of 12 miles per hour. But notice that there isn't a time element here. So you have to consider how fast he's moving, and then you figure out how far would it take him to go the 2 miles back to home, because we know exactly where he is based on how we've tracked him. So 12 miles per hour divided by 60 is 12 over 60, or 1 over 5. So he's going 1 mile every 5 minutes. Okay, that's actually pretty easy to understand. So if we're here at a height of 2 miles, we're going to drop 1 mile, there's the 1 right there, in 5 minutes. So now we're at minute 25. We're going to go down 1 more mile in 5 more minutes, and we end up right here at the end of the graph at 30. Okay, so and he's back home at that point. So the things that I didn't cover are how to find the equation of phase 3 and phase 4. Let's go back to phase 3. He was traveling 1 mile every 15 minutes. Remember that? Okay, that's how we calculated. And then, if you recall, you put plus blank because we don't know at this moment where this line is going to cross the y-axis. I could take a pretty good guess I could probably walk it back on the y-axis like that. But let's say you're not able to do that. You have to have an algebraic way to solve for it. And this is what we do. We set up y equals mx plus b, and you plug in for the rate. There's the 1/15 that you see right there. And then you plug in for a coordinate. Okay, so with the 1/15, I chose 20, 2, because that point right here is on the line. It's actually at the end of this line segment. I could have chosen 14, 1.6, but I like the 20 and 2 because there was no decimals involved. So I plugged in 20 for x right there, and 2 for y, and x for y, and we solved for b. And by doing that, we got 20 times 1/15, which is 4/3. Okay, and then subtract 4/3 from both sides, and it turns out to be 2/3. So that 2/3 you put right back here on the line. Okay, so we now have the full equation of phase 3, and you lay out the restrictions from time 14 to time 20, or minute 14 to minute 20, because it was a 6-minute interval. Okay. Now, on the last one here, the last phase, it's negative. Okay, I think I actually messed that up in real time in the Zoom. Somebody caught it, thankfully, and I would have caught it too. Actually, I did, because I was solving for the y-intercept over here, and I got the wrong thing. I was like, wait a minute, what's wrong with this? And so it's like, your slope should be negative. I was like, oh, right, okay, because you're going down. So again, we lay out y equals mx plus b. We change the rate to -1/5, okay, down 1/5. Plug in either coordinate. I chose to plug in 30, 0 because we'd already figured out that coordinate based on just the graph. Or you could have used 20, 2 again. That'd been fine. Either way, you're going to get the same answer, which is nice. So put the 30 in for x, put the 0 in for y, and do the work. 30 times -1/5 is -6. Add that 6 to both sides, and the y-intercept for phase 4 turns out to be 6, which I put on the line right there, with the time restriction of 10 minutes from minute 20 to minute 30. Okay. And always do like a quick check. Does that look right? If you continue this line up and back to the y-axis, does it seem like you would hit at 6? I would say that seems very reasonable. Yes. Okay. So that is what we covered in about 20 minutes. So you got like a 5 or 6 minute overview. But hopefully it's helpful. You got your notes down, and then you're ready for the next day. Have a good day.